So I FOILed to this step. The two middle terms with the i's canceled out because one was positive and one was negative. So then I have 9 here. This step right here, we learned in the last lesson, here's where we get the I squared is -1. This might not have been what you were asking, but it doesn't hurt to repeat it. In the last lesson, we learned that -1 square rooted simplifies to I. And then I talked about how if I squared both sides of that equation, which is okay to do because it's an equation, and as long as you do it to both sides, you're still going to have something that's true. I get I squared on the right, and on the left, the square cancels out the root, leaving me just the -1. And so then we talked about, okay, when you go to multiply complex numbers like we're doing in this warm-up, sometimes you'll have I times I, or I squared. And anytime that happens, you replace the I squared with -1. So that's what I'm going to do right here. Now, it's not that I wrote -36 minus 1. It's a -36 times -1, because it was 36 times I squared. So we're still doing a multiplication right there. And then -36 times -1 is positive 36. And so that's how I got 40. Good? Okay, you're welcome. If you've done a quiz retake or a test retake, and I just haven't seen it yet and updated your Skyward, you can leave a private comment in your Google Classroom on that assignment, because that will kick that will kick a Google notification over to my email, and I can go find it. You can also just email me about it. And when you email me, if you could do these things, please. Give me your class period, because I still don't have all of y'all memorized where you go. Give me your class period. Give me the assignment name, whatever the title is, and any other details you think. Plus also manners are pretty cool. I know sometimes y'all aren't, I don't just think you're not thinking, but you can be kind of bossy. And it's good practice to practice your email manners. It's very professional, and when you go off into the world, it'll serve you well. So it's a good thing to practice. Also, happy pre-Friday. I think everything's a countdown to Friday, so today's a pre-Friday. All right, so we are going to have a skill check like we did on Tuesday. So you can have your notes out and your homework. And as we go forward, if you're working asynchronously, on a day we have a skill check, you see how I made this slide like really bright blue? That way, if you're going to the video to find it, you know how you can like fast forward by sliding the little thing in YouTube, and it gives you like with these little previews of where you are? Just look for blue or whatever the color is, and you'll find the part of the video that you need for the skill check. So a few more, since skill checks are new for us, just a few more reminders. You do this on your own scratch paper. You show all your work. You will take a picture of it and submit it into the assignment in Google Classroom, and we will grade it together as soon as we're done, and I'll give you a minute to try and go post it. If you can't post it in class, you can by 11:59. So here's your problem. It says on a blank piece of paper, solve the following, show your steps, right? And if you're watching asynchronously, please pause the video now and work the problem before you listen to how we're going to grade it. Yes. So that is a great question. Mathematically, this answer is the same as my answer. However, and I will take it for a 100. But if you're in college, especially if you're like entering an answer into a computer program and it's specifically asking you for the A plus BI form, which most textbooks would do, and so therefore some software might, it could count it wrong. It depends on how it's set up, so be careful. So I'm good with it. That's your short answer. Put 100 if you wrote 37I minus 20. But it's general procedure to write it the other way. So it's a 100 if your answer is just like mine, either written the way I boxed it or the second way, 37I minus 20. It's a 95 if you made a simple math mistake, like you added wrong. It's an 85 if you did the I squared equals -1 part wrong. I do not consider that a simple mistake. That is a procedure mistake. So if you left I squared in your answer, that's at least an 85. If you did minus subtracting a 1 right here, if you did -10 minus 1 and got -11, that's a procedure mistake. That's an 85. I do not consider that a simple math mistake. It's the thing that we're learning. It's part of the procedure. If you did both kinds of mistakes, that's a 75. If you really didn't know what to do, but you did try, it's a 65. And if you consider yourself like you would have put IDK on this paper and turned it into me, that's a 0. But if you tried something, that's a 65. So please write your grade on your paper. Take a minute, go submit your picture in Google Classroom, and also write the answer in your private comment. So 2 things, post your picture and post your grade in the comment. You have a minute to do that. So we FOILed there, -30 plus 25i. I'm going really fast, so if I make a mistake, let me know. Just try not to waste too much of your time. Of course, by making mistakes, you end up wasting time. Kind of ironic. So I want you to look at these 2 things. And I want you to first look at the answers. And in the chat, please tell me what's different about the forms of the answers. What's missing in the first answer that's in the second answer on the right? What's missing in the left answer that's in the right answer? So please put that in the chat for me. So for those of you who put in the chat, here's what you said. The answer on the left is missing an I value, right? It does not have an imaginary part to it anymore. But look at the original problem on the left. There was I's everywhere. What is happening, and you can put this in the chat, what's the pattern in the 2 complex numbers in the left that made the I end up disappearing? The I values canceled, that's right. What made them? The I values canceled, so you were able to get a whole number. Matthew, that's perfect. That's exactly what happened. But there's a pattern in the original problem. And if that pattern is repeated in other problems, then the same thing will happen. The I will get canceled out. But we need to figure out what that pattern is. So compare the 2 original problems together, the highlighted yellow one and then the highlighted blue one. The I value is a perfect square root. I think I know where you're going with that. I think you're saying the I values look like the same, right? Is what you're saying? They were both 6i. What else is the same about these 2 things on the left? So let me sort of highlight again what I'm going for here. This is two different complex numbers. This one, the A values are the same, perfect. And this one, that's two different numbers, but they look very similar. There's really only one difference between the blue complex number and the purple complex number. What's the one thing? If you're just looking at them left to right, only one thing is different. And this is the pattern. One has positive, one has negative. That's right. So everything about these two is the same, except the sign in the middle. The negative 3's are the same. The 6 I's are the same. The sign in the middle is the only thing that's different. And that's not what's happening over here, right? The thing we just did in the skill check. It's all kinds of different stuff over there. So no I's canceled out. What we call these two kinds of numbers, where everything's the same except for the sign in the middle, we call those conjugates. And because we're talking about complex numbers, we call them complex conjugates. And that is the point of the lesson today. So let's begin. Here's your notes. So I'm on your notes page now. This first sentence says products of complex conjugates. So product means multiply, which that's what we were doing. Products of complex conjugates allow us to get back to real numbers. Real number because there's no more I in it. That's what happened. We started with two complex conjugates, which I'll describe how to figure that out here in a minute. We multiplied them and we got just a real number for our answer. There was no I part. For any complex number in the form a plus bi, the complex conjugate for it is the exact same thing, but with the plus changed to a minus. So for example, if my complex number was 5 plus 6i, to find its conjugate, all I have to change is the plus to a minus. And let me just throw some negatives in there so we can look at that too. Let's say everything was negative. Let's say I gave you -2 minus 5i. And I asked you for the complex conjugate. This is something that's very important. I need you to pay attention to. I'm not telling you to just take the opposite of every single sign in the problem. I'm telling you, you're only going to take the opposite of the middle sign. So if I were to ask you, hey, what's the complex conjugate of -2 minus 5i? The only sign you're changing is the one in the middle, so it would become plus. Everything else about the number stays the same. The -2 stays the same, and the 5i stays the same. Right? So be careful that you don't change more than is necessary. You're only changing the addition and subtraction part. And we're not going to do this part because we did this with the example. That's just general form. If I were to multiply this out and do FOIL like we did, Math Ensues, I would have this. So instead of foiling out every time, we're going to use this shortcut. Whatever the A value is will be squared, and whatever the B value is will be squared. So if we go back to our warm-up problem, which was this, remember the other day we did all that work about figure out the A, figure out the B? We're going to use that here. The A value is -3. The B value is -6. Notice it does not include the I. right? I said that a whole bunch the other day, almost to the point of annoying. Maybe it was to the point of annoying. But this is one of the reasons why. So that when we get to this shortcut right here, we know exactly what we're plugging in. So our answer in the warm-up was 45, and we foiled, but we could just do this and get the same thing. Watch. Square the A value plus squaring the B value and still get 45. What this shortcut does is bypass the step where the two middle terms canceled out. Remember, we had a negative 18i and a positive 18i? This shortcut just skips all that together. And this shortcut, though, is only for complex conjugates. It's like just a magic thing for this particular situation. Before we do some practice, does anybody need to screen up anymore? Okay, here we go. So this says, for each complex number, name the complex conjugate and then find the product. I want you to just write down the complex conjugates for each of those. You don't have to do any multiplying yet, just write down what you think it is and raise your hand as you finish. You don't have to keep your hand up. I'm looking at you. I just want to see. Thank you. Thank you. So we're just writing down what we think the conjugates are. Thank you. Thank you. And just raise your hand real fast when you're done. Okay, thank you, thank you. All right, so here's what the complex conjugates are. On the first one, you're only changing the subtraction to an addition. So raise your hand if you wrote 2 plus I. Okay, fabulous, excellent. On the second one, you're only changing the addition to subtraction. You're only changing the sign in the middle. The other sign on the -1 stays the same. So this becomes subtraction. That's the only change you're making. All right, who's good with that? Fabulous. All right, so now we find the products. That's the second thing. So the first one was just to name the conjugate, and the second one is to find the product, which means actually multiply those two things together. So that means we're going to do, technically this is what we're doing. 2 minus I times its conjugate. We could FOIL those, but we don't have to, because we have this shortcut, the A squared plus B squared thing. You just have to be good that you know what the A is and what the B is. The A and B here, in this case, you're not going to include the sign. It's just the A part and the B part. So the A is 2, and the B is just 1. I'm going to show this formula again. Technically, the B is a little bit different than what we talked about the other day, and that can be confusing. In fact, if you don't like this shortcut, you can just do FOIL every time. It's just a good shortcut for people who like shortcuts. For the second pair of conjugates, what's in the A position according to this formula, what's here and here is the negative 1. And what's in the B position, which is here and here, not including the signs today, is the square root of 5. The formula already accounts for the fact that the imaginary part has opposite signs. Because you might be like, well, which sign do I take or which one? You don't. You just take the B part, just the number part, strictly the number part. And then we square that, a squared plus b squared. The square root of negative 1 is 1, positive. And the square root of 5 show me with your hands and with your fingers. What's square root of 5 squared? Thank you. Okay, thank you. This could be something you might be like, I don't remember. Okay, 5. Thank you. 6. Right? Do the shortcut if you like it. If you don't like it, you can FOIL things all day long if you feel more secure with foiling. Does anybody need the screen up anymore? Okay. We're going to cut out the fractions because give us a break. But for this other problem on here, it says name the complex conjugate, then find the product. This is kind of weird because there's no A value. And what did we do the other day when we didn't have an A value? What did we put in its place? 0. Thank you, Dylan. So really what I have going on is this. 0 minus 5i. And so to do the conjugate of it is just like we did the other ones. The only thing you're changing is the minus in the middle to a plus. But everything else stays the same. And then you just do your a squared and your b squared. The a is 0. The b is just the 5 today because they have different signs. So you can't really include a sign because you'd be like, well, which one am I including, the negative or the positive? You're not. The formula already takes into account that they have different signs. So you just use the number that's being multiplied. So a squared plus b squared is 0 squared plus 5 squared. That is 25. Now let's go. And we're skipping the fractions because it's pre-Friday. And it's a good day to skip fractions. Does anybody need this up anymore? All righty, thank you. Try this problem on your own, please. You're welcome to do the shortcut. You're welcome to do FOIL. In the chat, when you put your answer, tell me if you did the shortcut or FOIL. So 2 things in the chat, your answer and your method. The method choices are shortcut or FOIL. So for the shortcut, you just had to determine what the A value is and the B value. So A was -2 and B was 7. And so when you go to square them, please understand something about squaring the -2. The negative is part of the number. So when you square it, it means -2 times -2. So the sign on that is +4. +4. So you should have 53. If you had 45, pretty sure you said that -2 squared was -4. You squared the 2, but you didn't square the sign. And if you foiled and didn't get 53, let me show you the work real fast so you can find your mistake. You should have 4 minus 14i plus 14i minus 49i squared. The i's in the middle drop out. 4 minus 49 times a negative 1, because I squared is negative 1, which means 4 plus 49, which is 50. Right, so either way, you have 53. And then we're going to take a little brain break before we do the last two problems. I have a poll for you. It's completely pointless and silly. Let's kind of set this up actually a little bit. We do have a complex number. It's negative 3 plus I. But, thank you, Isabel, that's correct. But the fact that it's squared means what I really have going on is this. Negative 3 plus I times itself. So negative 3 plus I times negative 3 plus I. How come I can't do the shortcut on this one? So you should have 8 minus 6i. And one more time, just to repeat, because I didn't get this on video before. The reason why we can't do the shortcut here is because they have the same sign in the middle, not opposite signs. So we had to just FOIL like normal. All right. One last problem. True or false, put it in the chat. I can do the shortcut on this problem, true or false. If you're unsure, let's talk again about what this notation means. The squared means the thing inside the parentheses times itself. And so now that you've seen it like that, is it true or false that we can do the shortcut? All right, good job, y'all. It is false. So if you can't do the shortcut, you're just going to do plain old-fashioned FOIL. So I'm going to, the answer has a radical. So when you put your answer in the chat, just put rad when you get to that part of your answer. And if you're watching the video and you're working asynchronously, pause your video now and work the problem on your own before you watch the work. Okay? So to do FOIL, it's, yes, Matthew, that's right. We do the first terms, the 5 times 5, which is positive 25. And then 5 times that outside term is negative 5i rad 3. And then the inside terms, these two, is again negative 5i rad 3. And then these two outside terms, you multiply what's on the outside of the radical, which is negative I times negative I. So it's plus I squared. And then you multiply what's inside the radical, the 3 times the 3, which is 9. And I'm going to kind of just pause there because I'm guessing that was the main part of the problem. If you were stuck, that's where you were stuck. So let me say that again. When you're multiplying radicals, there's 2 pieces to look at, just like when we were adding. You multiply the outside pieces together. So negative I times negative I gave me I squared positive. And then you multiply what's inside the radicals together. So it's radical, and then 3 times 3 is 9. When we were adding and subtracting radicals on Tuesday, we added and subtracted that blue part, but we didn't change the part that was purple. We would have just left it 3 when we were doing the addition or subtraction. But today, when we're multiplying, we multiply what's on the outside and we multiply what's on the inside. And so then here's what the next step would look like. For right now, my 25 stays 25 because there's nothing I can combine with it. Those two middle terms, excuse me, it's an addition subtraction problem. When you're adding or subtracting radicals, the radical part stays the same. And you might want to write that down somewhere on your notes. Adding, subtracting radicals. Here's what you need to know about that. The radical doesn't change. And you add or subtract the number in front. So in this case, the radical 3 stays the same. What I'm going to be adding and subtracting is this negative 5i and this negative 5i. So negative 5i, negative 5i is negative 10i. So that goes in front of my radical 3. And then a minute ago when I was talking about multiplying radicals, what I reminded you of is that you multiply the numbers in front together, or I should say outside, let's say outside. So multiply numbers that outside together, and then you multiply the numbers inside together. So that's a quick review of the differences when you're adding, subtracting radicals, or when you're multiplying radicals. And that's what got me that I squared square root of 9, which I'm going to do some more work on right now. So remember that I squared is replaced with negative 1. Square root of 9 simplifies to 3. What math is happening between that negative 1 and that 3? Are they being added, subtracted, or multiplied? It's a multiplication because it was I squared times the square root of 9. So those simplify to negative 1 times 3. And so I only have one more step here. This 25 can now combine with this negative 1 times 3, which is negative 3. Those give me 22. So let's say this problem, and you were like, gosh, I don't remember the radical rules. I know she said that, but I didn't remember that. I want some more practice. You can come in for tutoring. Also, if you want to go Google stuff yourself and you just don't know what to search for because you don't know what the words are, You could search either Google, or you can go to Khan Academy online, which always has lots of good videos. You can come into tutoring and we can just go over some problems. But what you would be looking for is you could search for operations on radicals, or you could specifically search for add, subtract radicals, multiply radicals. But if you use the word operations, you'll get results for add, subtract, multiply. So we are done